All right, today we're going to discuss the next two sections. Section 2 deals with polynomial and rational functions. And section 3 deals with polynomial division. And it discusses the remainder theorem and the factor theorem. Now we're getting close to being able to solve our own equations. For example, x cubed plus 4x squared plus 8x plus 32 equals 0. How would you solve that? No, it's already, that's a good point. You always want to set it so it's the highest exponent down to the constant in decreasing order. You could try to factor it, but how many factors are we going to have? Yeah. What's the degree? So we're going to have 3 solutions. That means we're going to have 3 factors. So factoring right now, we wouldn't know where to start. And that's where we're getting to. But we have another factoring method that's called grouping. Because we have 4 terms, grouping only works when you have 4 terms. If you group the first 2 terms plus group the last 2 terms, we can see if there's a resulting factor that's the same. So what can you factor out of the first set? You take an x squared out. If you take out an x squared, what do you have left? Very good. How about the second set? So if whenever you factor a number out, you divide that to see what was in the parentheses. So 8's cancel. 32 divided by 8 is. So we went from 4 terms down to 2 terms. Now what do we do? Do the 2 terms have anything in common? They both have an x plus 4, so we factor that out. Whatever's left goes inside this next parenthesis, which is x squared plus 8. In other words, whatever the coefficients are. So now we have our 2 factors. What we do here, set them equal to 0 and solve. So this one becomes -4. Subtract 8 from both sides. Square root both sides. So we have x equals plus or minus. There's a negative inside there. So that becomes an I. What is 8? Can we factor anything out of that one? Yeah, 8 is made up of 2 times 4. So it's really 2 times 2 times 2. Since there are two of a kind, we can take it out. So those are our three factors. X plus 4 is our first factor. X minus 2i radical 2. And then x plus 2i radical 2. Those are our factors. So what would the graph look like? If our intercepts were at -4, 2i radical 2, -2i radical 2, what would our graph look like if our intercepts are these? Yeah, these are imaginary, so that's not an intercept. So we have here will look something like this. All right, next page. Any questions so far? Oh, then graph this function. -2x to the 4th plus 3x cubed. Anything factor out? Yep. Leaving us with the resulting amount. We also factor out a negative. You never want to have a negative coefficient inside the parentheses, so we'd factor out a negative x cubed. That would change the signs inside there. Remember, our degree is 4. Our multiplicities, if we add them, we get 4. So now once we did that, set them equal to 0. So this one, since it's a constant, a single term, makes it 0. This one, you have to add 3 to both sides. 2x equals 3 and divide by 2. So x equals 3 over 2 or 1 1/2. Really quick. If I gave you this equation there, what would x equal? How about that one? Yeah, because we learned it's always the opposite of what's inside the parentheses, right? The same thing works if we have a coefficient. It's still going to be the opposite of what that one is, divided by a coefficient in front of x. So that's a shortcut. So you don't have to spend all this extra time moving things around. So we have our intercepts. We have our multiplicities. we have the zeros and multiplicities. We talked about multiplicities, didn't we? Yes. So it's 0 and 1 1/2, or 3/2. What's the multiplicity of 0? Multiplicity is the exponent. How many times it occurs? That one's 3, and the 2x minus 3, it only occurs once. So its multiplicity is 1. Since the multiplicities are odd numbers, they cross the x-axis at those points, at these zeros. So at 0, and at 1 1/2. Those are my intercepts. All right, then what's our graph going to look like? Remember, very good. Yeah, so because it's the degree is 4, which means both ends have to point the same direction. It's going to look either like that or like that. Since the coefficient is negative, they point down. So since these are my intercepts, the graph has to point down from there. And since the multiplicities are odd, the graph crosses the x-axis. It looks something like this, where if we plug in 1, we get positive 1. Yeah, so factoring out, what we're trying to get to, the important thing is, we start off with a polynomial. We're trying to get to the factored form, because once we get to the factored form, we set them equal to 0, and it gives us our intercepts, and we begin from there.
Can you explain how negative x cubed equals 0?
Oh,
It's just a logic thing.
okay. Yeah, well, first off, it changes signs. 0 has no sign, so that goes to positive that. If we cube root both sides, yeah, so it's, if x is by itself, it's, if we had even like 5x equals 0, it's still going to be 0. The only way it could change is if it's got a plus or minus to it. Let's look at this example. Tell me the intercepts. Tell me what the graph looks like.
Same thing as before.
Right, because we know that the degree is 4. That means we'll have n minus 1, we'll have 4 intercepts. We'll have n minus 1 vertices. So we'll have 3 vertices, which are turning points. The y-intercept is at negative 16. But right now, looking at this equation doesn't mean much to you, other than the first and last. How about if I gave you this? That's the factored form of that equation. Now we set them all equal 0, right? But before we do that, let's look at something else. But you're right, we'll eventually have to, notice we have 2 of a kind here, same one. So let's put, because these exponents here are called the multiplicities. They're important because if the multiplicity is odd, the graph crosses the x-axis there at that point. If it's even, the graph bounces off the x-axis there. So knowing the multiplicity of the factors is important. So now we find our zeros. And state their multiplicities and determine whether it crosses or bounces. Our first 0, second 0, and third. -1, 2, and 4. Next week at this time, I'll be able to give you guys an equation like this, and you will be able to find the factors yourself. Right now, it's much easier if I give it to you first. Let's talk about those. So what's the multiplicity of -1? Yeah, it only happens once. Of 2 and of 4. If we add all those multiplicities, we get the degree. So if we add up all the multiplicities, we get the degree. So the first one is 1. Does it cross or bounce? 2. 1. Right. So we know what happens on the x-axis at those points. And we know our graph crosses the y-axis at -16. So at -1, 2, and 4, we have our x-intercepts. We know it's a degree 4 equation, and the leading coefficient is positive, so the graph opens up. So that means at the outside of both ends, they go up. At -1, it crosses. At 2, it bounces. And at 4, it crosses. So it looks something like this. All right, so again, once you have the factored form, it becomes a lot easier to figure out what the graph looks like.
That third, or next.
Right. Right. And yeah, and those we don't know, we have to plug in points. the intermediate value theorem, or IVT. The intermediate value theorem states this: for any polynomial P of x, where A, B, and C are integers, on the domain of x, of P of x. So intermediate value theorem. If P of x is a polynomial where A, B, and C are integers on the domain of P of x, and if P at the value A, let's say, is positive, and P at the value B is negative, then there exists at least one value C where C is between A and B, such that the value at that point is 0. In other words, C equals the x-intercept. Can you think of what that means? I know it's a lot of words, but the true meaning of this is this. If I have a graph, at point A, I have a point up there. That's P of A. And at B, I have another point down there. If I was to connect them, because remember, polynomials have to be continuous functions, that means at some point between there, it has to cross the x-axis. The P of x, the P of C has to equal 0. It doesn't, this IVT doesn't tell us how many or where they are. It just tells us that one exists. And that's where it's find out where that is. In other words, if we find two values and there's nothing there, if they're both the same signs, we don't have to worry about, is there an x-intercept there? There's no solution between there. Let's look at a couple examples. P of x is the function x cubed plus x squared minus 6x. A is -4 and B is -2. So between the points 4 and 2, does the graph cross the x-axis? Is there a solution between 4 and 2, or -4, -2? So we'd simply say A is x is -4 and then x is -2. Plug those in the functions. We have -4 cubed plus -4 squared minus 6 times -4. -2 cubed plus -2 squared minus 6 times -2. So work those out. -4 cubed. Since it's cubed, the answer is going to be negative. 4 cubed is 64. 4 negative squared is positive. 4 squared is 16. Negative negative is positive. 6 times 4 is 24. They're both positives. 16 plus 24 is 40. 64 is bigger, so the answer is negative. 64 minus 40 is -24. -2 cubed. Negative cubed is still negative. 2 cubed is 8. -2 squared is 4. Negative negative is a positive. 6 times 2 is 12. Four plus 12 is 16. 16 minus 8 is 8. So what does that tell us? We know that P of X equals 0 at some point between -4 and -2. Because the values are different, that means there's a number between there where it equals 0. So let's look for it. Let's factor it. All three of them have one X in common. I can factor the quadratic, X and X. Second sign's a negative, so that means they're different. One's positive, one's negative. And the bigger number gets the plus. What times what equals 6? When you subtract them, you equal 1. Three times 2, 3 minus 2. So remember, it's a third order equation. We have 3 factors. Solve them for 0. We get X equals 0, X equals -3, and X equals 2. We knew about this one. Because isn't -3 between -4 and -2? So that's what the intermediate value theorem is telling us. Let's try this one. A equals 1 and B equals 2. Is there going to be an x-intercept between there? X equals 1 and X equals 2. Third, 1 to the 4th minus 1 to the 3rd. Third, 2 to the 4th minus 2 to the 3rd. One to the 4th is just 1, so I get 1/3 minus 1. One is the same thing as 3/3. Because we come denominator 3. So 1 minus 3/3 gives us negative 2/3. There's our first point. What do we get on the second one? 2 to the 4th. 2 times 16, very good. 2 to the 3rd is 8, 8/1. So we got 16/3 minus 8/1. With a common denominator, so it's 3. 16/3 minus 24/3. 16 minus 24/3, negative 8/3. So what does that tell us? They're both negatives. There's no x-intercept between x equals 1 and 2 because they're both the same signs. The intermediate value theorem can't tell us anything. So this tells us that we know we don't have them. So that's all section 2 is all about. We're learning how to manipulate these polynomials because in section 3, we're going to start learning the mechanics of how to get our final answers. Section 3 deals with polynomial division. And then with that, we're going to talk about the remainder theorem. And with that, the factor theorem. THM is short for theorem. The division, polynomial, and the remainder theorem, they'll both be pretty much introduced at the same time. So let's look at an example. So factor that one out. So we know it's x and x. Because it's a plus, the signs are the same. they're both going to be the first sign. They're both going to be minus. So these last numbers, what times what equals 6 when we add them, we equal 5. Yep, 3 times 2 is 6, 3 plus 2 is 5. So from there, we set them equal to 0, we get our solutions, x equals 3, and x equals 2. So what exactly are these numbers? What do they represent? They're x-intercepts, very good. What else? They're zeros. Why are they zeros? No, that's how you get this.
When you plug it in.
Yes, if you plug in 3 or 2 inside this original equation, it comes out to be 0. That's why it's a 0. What else is it? Yeah, factors, solutions. If I said the 0 was 3, x equals 3, you can work backwards. That'll give you the factor. But what we're saying is this: x squared minus 5x plus 6 can be factored into x minus 3, x minus 2. That's all been proven so far. So let's look at division. Let's look at division to prove this. If we take our original polynomial and divide it by x minus 3, let's see what we'll get. Well, we know what we should get, because if we factor out the numerator, we get this. The x minus 3's can cancel. We should get x minus 2 as an answer. But let's see how we do it. You've been doing long division your entire life. Not wrong division, long division. For example, if I gave you 42 divided by 8, what you would do is 8 goes into 42. Okay, so how many times is 8 go into 42? 8 times 5 is what? 40. So 5, it goes in there 5 times. 8 times 5 is 40. And then what do? We subtract it. We change the sign. It used to be positive. Now we subtract it. 8 does not go into 2. So this is our remainder. The answer really is, for this one, it's 5 plus 2 over 8. Whatever the remainder is over the denominator. We do the same thing here with polynomials. Whatever's on the bottom goes to the side. And the polynomial goes inside that divisor. Here's a note. You notice that the exponents of the variables have to be decreasing. 2, 1, 0. If you're missing one, you have to put a 0 in that location. If you're missing a variable then you have to put a 0 there. You have to have all the columns allocated. Okay, this is called long division. So the way you just concentrate, focus on the leading terms. What times x gives me x squared? X. So from here, I take this x and multiply it to x minus 3. X times x is x squared. X times negative 3 is negative 3x. Change their signs. Notice I'm subtracting. And add. The first term should always disappear. Negative 5 plus 3 is negative 2x. And bring everything else down. Repeat the process. What times x gives me negative 2x? Negative 2. So I take the negative 2 and multiply it to x. I get negative 2x. Negative 2 times negative 3 is positive 6. Change the signs and add. Sure enough, our answer is x minus 2, which we suggest supposed. It tells us two things then. Long division tells us two things, three things. It tells us first, whether the denominator is a factor of the numerator. If the remainder is 0, then the denominator is a factor of the numerator. If the remainder is 0, then the denominator is a factor of the numerator. And whatever is on top, whatever the answer resulting is, the quotient, this is called the quotient. That's also a factor. We can go further now. So far, so good. Let's do another one. X squared minus 7x plus 12 divided by x plus 3. Tell me the quotient function and the remainder function. And then B is x plus 3, a factor of x squared minus 7x plus 12. So we do long division. X plus 3 x squared minus 7x plus 12. Look at the leading terms. What times x gives me x squared? X. Take this, multiply both of those. X times x is x squared. X times positive 3 is positive 3x. Change the signs and add. First one always has to cancel. If it doesn't, you did something wrong. -7, -3 is -10. Bring down everything else. Repeat the process. What times x gives me -10x? -10. So -10 times x is -10x. -10 times positive 3 is -30. Change the signs and add. There's your remainder. And there's your quotient. So the quotient is x minus 10, and the remainder is 42. So is x plus 3 a factor of our numerator? No. Because the remainder is not 0. Let's try another one. Since we know x plus 3 doesn't work, let's try x minus 3. It's going to be the quotient function and the remainder function. X minus 3 x squared minus 7x plus 12. So what's my first term? Now, what times x squared? X. So x times x is x squared. X times -3 is -3x. Change the signs and add. -7, 3, 7 is bigger, so it's negative. 7 minus 3 is 4. Bring down the 12. What times x gives me -4x? -4. So -4 times x is -4x. -4 times -3 is +12. Change the signs and add. So the quotient is x minus 4. The remainder is 0. So yes, x minus 3 is a factor of x squared minus 7 plus 12. Do we know the other factor? Yeah. X minus 4 is the other. Exactly. Is there an easier way of doing this? We'll try another way. Since we know that x minus 3 is a factor of x squared minus 7x plus 12. It's a 0, isn't it? Since it's a factor, it's also a 0. So x equals 3. What happens if we plug in 3 into our function? Three squared minus 7 times 3 plus 12. 3 squared is 9. 7 times 3 is 21. 9 plus 12 is 21. So in other words, if you don't feel comfortable doing long division, what you could do is just find the 0 of that denominator and plug it into the equation. That's another way of doing it. The bad part about doing it that way is, so we know that 3 or x minus 3 is a factor, right? But we don't know nothing else. We know nothing about the other factors. We'd have to do division anyway to get to it. But if we do long division and we get a 0 remainder, then we know the factors. So it does two things for us. Okay. Factor this equation out for me. With what we've discussed so far, factor this out for me. How would you do it? How would you do it? How would you do it? Yeah, but we noticed that grouping won't work because this is 5 and 6. It won't fit in there. So you're right. The first thing we do is check out grouping, but that doesn't work. So what's our next step? Divide what? You're right. The next step would be to try division. If we did division, we would try x plus 1, x minus 1, x plus 2, x minus 2, x plus 3, x minus 3. That's a lot of writing. Or we could just do the solution to those. We can try 1, negative 1, 2, negative 2, 3, negative 3 by plugging in the equation. In other words, we try f of 1, f of negative 1, f of 2, f of negative 2, and see which ones equal 0. We could do it that way. So which way do you think? Remember, this way, if you do it this way, inside there, it just tells us if we have a 0. It doesn't tell us what the remaining functions are. If we did it this way, long division, then we'll know what the resulting function is. So let's try this method. I like not this yet, not this one yet. So let's try x plus 1 x cubed plus 2x squared minus 5x minus 6. So what times x gives me x cubed? X squared. So x squared times x is x cubed. X squared times 1 is 1x squared. Change the signs and add. 2 minus 1 is 1. Bring down everything else. What times x gives me x squared? A positive x. So x times x is x squared. X times 1 is positive x. Change signs and add. First one cancels. Negative 5 minus 1 is negative 6x minus 6. What times x gives me negative 6x? Negative 6. Negative 6 times x is negative 6x. Negative 6 times 1 is negative 6. Change the signs and add. So x plus 1 is a factor. Now the hard part's over. We don't have to do this long division anymore because all we have to look at now is the quotient. Try to factor that one out. X, second times a minus, so they're different. One's plus, one's minus. Bigger number gets a plus. What times what equals 6? When you subtract them, you get 1. Yeah, 3 and 2. So 3 gets a plus. So those are your factors. X plus 1, x minus 2, x plus 3. What do you think? A lot of writing. Because if what we got lucky is the first, if it didn't work on the first one, we'd have to do the same thing with x minus 1. And so on and so forth. So what we've talked about so far deals with the remainder theorem. The remainder theorem says this: if C is a solution of P of X, making P of C equals 0, then we know that a factor of P of X is X plus or minus C. That leads us to the more important topic. Synthetic division. This way is a lot faster, but it only works on denominators that are of the form x plus or minus c. In other words, the x, the denominator, cannot have a coefficient or an exponent. It just has to be an x plus or minus a number. If that's the case, then we can use synthetic division. So in this example, we can use synthetic division. And here's the beautiful part. Can we do long division with the amount of space I have left? No. But I can do synthetic division. The way you do synthetic division is first, take the denominator and solve it. So x equals -1. So that's what we're going to use, -1. Synthetic division is upside down division symbol. We only use coefficients. There are no letters in synthetic division. So what's the coefficient of x cubed? What's the coefficient of x squared? And then of x, here's x. And then there's the constant is, so it starts with the highest exponent and it works its way down to the constant. If one of the variables isn't in the equation, put a 0 below it. All right, here's a structure. This number out here, its only purpose is to multiply by the numbers that are down here. So whatever, and we go by columns. Whatever you get here goes in that space. And whatever you get there goes there. And up and down, we add. So there's nothing there. So 1 plus 0 is 1. So -1 times 1 is -1. Remember, top down, add. 2 minus 1 is 1. -1 times 1 is -1. Add. -5 plus -1 is -6. -1 times -6 is 6. And we add -6 plus 6 is 0. This is your remainder. That means x equals -1 is a solution, which means that x plus 1 is a factor. And this is the remaining function. Since we started off with x cubed, we lost 1x. So now this one starts off as x squared. It's a positive 1. So it's x minus 6. So it's x squared plus x minus 6. All this stuff, same thing we ended up here. After all of that stuff. That's synthetic division. It makes life a lot easier for us. Let's do another one. We have to know how to do synthetic division because that's what the next section is all about. So. Two x cubed plus 7x squared minus 5 divided by x plus 3. Now, the way this thing really looks, it's like that. So can we use synthetic division? Yes. First step is solve the denominator. So we get -3. The largest x variable is x cubed. So then we need x squared, then an x, and then a constant. What's the coefficient of x cubed? X squared. X. Yep. And constant. Remember, there's nothing there, so we add. We got 2. -3 times 2 equals -6. Add straight down. 7 minus 6 is 1. -3 times 1 equals -3. Add straight down. 0 minus 3 is -3. And multiply. -3 times -3 is +9. 9 minus 5 is 4. There's your remainder. So x plus 3 is not a factor of the numerator. Because it's not 0. Okay. Any questions so far? Does it make sense? It's not a factor, right? Exactly the same as synthetic division. I mean, long division. If the remainder isn't a 0, then we'll have, it's not a complete factor because we have a remainder there. Look at this 4 here. Remember, we had the value x plus 3. And we would try to put it in there. We solved it, got -3. What happens if we put -3 inside our function? So -3 cubed is going to be negative. 3 squared, 3 cubed is 27. -3 squared is going to be positive. 3 squared is 9. -2 times 27. I could have just left the negative aside there. 2 times -27 is -54. 7 times 9 is 63. Minus 5. -54 minus 5 is -59. 63 minus 59 is 4. So what this shows us, that if I give you a big equation and ask you to plug a number in there, you could do this, which is long and tedious and drawn out, or you just use synthetic division and work it out that way. It saves you lots of time. Here's an example of it. F of x equals 2x to the 5th minus 3x to the 4th plus x cubed minus 2x squared plus x minus 8. Find f of 10. How many of you are plugging 10 inside the equation? You see it, that, I mean, you have to take 10 to the 5th. If you just write it, yeah. So we just showed you the last example. We could simply use synthetic division. X to the 5th, x to the 4th, x cubed, squared, x, and constant. So the coefficient of the first one. Next one. Next one. And we're lucky because it's 10. So 2 plus 0 is 2. Let's go. This number only multiplies to these numbers. 10 times 2, 20. 20 minus 3, 17. 10 times 17. Just put a 0 at the end of the number. Remember, straight down you add. 170 plus 1 is 171. Times 10, 1710. Subtract 2, 1708. Times 10, 17080. Plus 1, 17081. Times 10, 170810. Minus 8. There's what it equals. F of 10 equals 170,802. Yeah, you're right. I mean, if you plugged in 10 in place of all those x's, it would take you way too long just writing it. Yes. Yeah, because there's nothing there, nothing to multiply by, because the numbers on this row here came from this times this equals that. And there's nothing to multiply here. Yeah, just bring the first one down. Yeah. So that's a cool way of doing multiplication. Is 5 a 0 of g of x equals x to the 4th minus 26x squared plus 25. I mean, the fastest way of just taking a guess is 50-50 shot. But mathematically, how do you do it? Yep. So we have x to the fourth, we have x cubed, x squared, x, and a constant. The coefficient of x to the fourth? 1. We have no x cubes. Negative 26 for x squared. There's no x's, and there's 25 of those. So 1 times 5 is 5. 5 plus 0 is 5. And then 5 times 5 is 25. Add these, 25, negative 26 plus 25 is negative 1. 5 times negative 1 is negative 5. Add these, 0 plus negative 5 is negative 5. Remember, all this one does is multiply by these numbers. So 5 times negative 5 is negative 25. 25 minus 25 is 0. So 5 is a 0 of x to the fourth minus 26x squared. If 5 is a 0, then what's a factor? Yeah, because if x equals 5, then we have to subtract 5 to make it equal 0. So this is our factor. X minus 5 is a factor. Remember, you have to start thinking backwards. Because if I gave you x minus 5, what would you put for synthetic division? You'd put 5. So it's always the opposites. Ooh. Is I a 0 of this function? We can have all sorts of solutions here. Nope, I squared means negative 1. So we do long division, synthetic division. X cubed, x squared, x, and a constant. So it's 1, negative 3, 1. Don't get confused because of the I. I times 1 is, I. Now add these. Negative 3 plus I. No, it's negative 3 plus I. They're not like terms, so you can't combine them. I times negative 3I is I times negative 3 plus I is negative 3I plus I squared. But I squared is -1. So that becomes -3i plus 1. Or -1. I'm sorry, -1. So -3i minus 1 plus 1 is just 3i because the ones cancel. I times 3i is 3i squared, becomes -3. Plus or minus. Oh, it's supposed to be -3, I'm sorry. Yeah. So it should be positive. So it's be -3. So -3 times I makes it a positive I. 3, -3 makes it 0. So I is a 0. X minus I is a factor. And the beautiful thing is, whenever we have complex numbers, they always come in conjugate pairs. Since x minus I is an answer, x plus I has to be an answer. So we have 2 of the factors already gone. So for next time, do this and bring it back to me with what we've learned today. And also, please watch the videos. That way, if we watch the videos, then we could speed up this process. And if any of you all want, I have some sunglasses. I gave you all sunglasses before. Have you need sunglasses before? Again. Or if you want green. Yes.
I want the log
Excellent. Yeah. I have that one.
and stuff on this because it's looking for an exact answer. And I looked at the example, I did from the program, and I'm not.
One of both.
Next week.
Yes, have a good weekend. Be safe. X is on one side. Right up the X. Yeah, because all of these LNs are solid numbers. Okay, we can look at first off, whenever you have ln minus ln, can you combine those?
Yeah.
ln is 6, yeah, there's ln 6 divided by 2 makes it ln 3.
Right.
So this is ln 2 divided by ln 3.
Well, that's one element.
Yeah, 1 times, yeah.
Oh,
1 times anything is 1.
so just 2 divided by 3.
ln not really that, because ln 2 is not smaller than
Right.
2. So what you would have there is ln 2 divided by ln 3. Don't use calculators for that.
Okay, and you could just take that number.
Right.
Good. Thank you.
Very good.
trying to make